Hello, my name is Joseph Cameron, and today I'm going to be talking about loudness normalization in streaming and broadcast services. So let's get started. Today we're going to be covering what loudness is and what loudness normalization is. We're going to be talking about why loudness normalization is important. We're also going to look at how perceived loudness can be measured from an audio file, and there are a couple of different ways of doing this. We're going to look at the actual techniques that streaming services like Spotify and broadcasting services like the BBC actually use to achieve loudness normalization as well. So first, what does loudness normalization mean? Well, simply put, it is the process of adjusting the intensity of audio to achieve a desired level of loudness. So essentially we're looking at the average loudness of an audio file and then turning the volume up or down as we wish. Importantly, when I'm talking about loudness here, I'm talking about perceived loudness. So how loud does it appear to be for a human listening? That's what I mean by loudness. Not the literal intensity of the file, but how loud we perceive it. To normalize multiple files, we just adjust all of them to a desired loudness. Why is this important? Well, it's very important because audio originating from different places can have drastically different volume. And to show you what I'm talking about, we're now going to head over to Logic to take a look at some audio. Hello. So here we are in Logic, which is a digital audio workstation. So I can have a look at audio here. You can see I've loaded up some songs already. A variety of songs. So here we have Grieg, one of Grieg's very famous pieces. Take a listen. So and all the way to Levels by Avicii. And so those are the songs that we'll be dealing with. And if you're not familiar with how volume is measured, essentially we have a 0 dB ceiling, and from there it goes negative. So if we play Levels here, you can see that it was hitting 0 dB there, and you could also see the instantaneous volume as well. So now I've magically got all my level meters for all the songs up at the same time. So now we're going to play them all and have a look at the loudness. So obviously I'm going to keep it muted so I can keep talking. But here you see RMS. And for now, we can take that as a measure of average loudness over the whole song. And we can also see true peak values as well. So that what is the loudest instantaneous volume in that song? And we can just see how different they are. So look at Grieg here, the classical piece. Minus 38 dB RMS compared to Avicii Levels at minus 8 RMS. And all the other songs are different as well, like Daft Punk, One More Time, minus 11. So In the Air Tonight is also minus 11. But you can just get a feel there for how different all their volumes actually are. So as we saw in Logic there, songs can have very different volumes. This can cause issues. So one of the most obvious problems is that if we were to play these songs in a playlist, for example on Spotify, there would be such big differences in volume that it would be jarring and actually quite annoying. For example, if you played Levels by Avicii, which is minus 8 dB RMS, straight after Grieg at minus 40 dB RMS, you're probably going to have to manually adjust volume to compensate for the difference, which is really annoying. And also, it's just jarring and not a very nice user experience. So that's an issue. And on the same note, if you're an artist making an album, you don't want to have your songs in your album at drastically different volumes. It'd be nice to have a consistent level throughout the entire album. And the second big reason why different volumes can cause an issue is because people typically will perceive louder audio as better audio. And this is a phenomenon that's been researched quite heavily, and these are a couple of papers here that I'm showing that are really good reads. If you want to know more about that phenomenon, then these are great papers to look at. But essentially, the paper on the left there, they had a really cool experiment where they played the exact same audio to people, just at different volumes, and people tended to prefer the louder audio file. And so songs and music have been progressively getting louder as a result of that phenomenon. And the name attributed to this typically is the loudness war. And it's an issue because it's not an entirely reflective or fair assessment of music. So we want to try and level the playing field between music and not just have people pick a song because it's louder than another. So yeah, that's actually a very big reason for why streaming services implement loudness normalization. Eventually the music industry could see that the trend for more loudness would spiral out of control. And so streaming services like Spotify decided to step in, and they would like to automatically play back music at a consistent level for a better user experience, so you don't have to manually adjust volumes. And it's also an attempt to combat the loudness war, to encourage mastering engineers to master for sound quality over loudness. And also, it must be mentioned that broadcasting services like TV channels, they want to keep consistent audio as well. Think about commercials. You want to have your commercials all playing at the same loudness. You want to have all your sound effects playing at the same loudness. Although, before we go about normalizing the loudness of audio, we first need to know how to measure it. So a really basic way of measuring the average intensity of an audio signal is through using the root mean square. And we already saw this actually in Logic before. And it's really useful because we want to know the average intensity of an entire audio file or an entire song. And its units are in decibels, and it's calculated like this. You essentially square all of your samples from your audio signal, divide it by the number of samples, and then take the square root of that. And the reason why we're using the root mean square is because our audio signal will have positive amplitude values and negative amplitude values. So RMS gives us the average intensity, but it doesn't necessarily give us the perceived loudness. For that, we need to take a few extra measures. So the extra measure that we take to measure perceived loudness is to essentially apply knowledge of loudness contours. So remember we said that volume and perceived loudness are different. And that's because humans perceive loudness differently at different frequencies. So you can see here from these figures that for frequencies below 1,000 hertz, it's essentially harder and harder for us to hear those frequencies the lower they get. And we can also see that we're actually particularly sensitive. We find it very easy to hear frequencies in the 2K to 5K hertz range. So if we apply this knowledge to the root mean square, then we'll get perceived loudness. And that gives us a measurement called LUFS. So what we do is we first apply a filter like the loudness contours. In fact, the actual filters we use are these. Essentially, we first increase the amplitude of frequencies above 1000 Hz, and then we slightly decrease the amplitude of frequencies below 100 Hz. Doing that to our signal first is called K-weighting. And if we do that before the RMS process, then we get loudness units relative to full scale, also known as LUFS. And this is how we want to measure our audio for perceived loudness. They're the standard units, and they're also known as loudness K-weighted relative to full scale LKFS, but they're exactly the same thing. LUFS are equal to LKFS, and this is really important to remember that one LUF, one loudness unit full scale, is equal to 1 decibel. Okay, so now that we know how to calculate the loudness of an audio file, let's head over to Logic and do that. So here we are in Logic, and we're going to measure the loudness of our tracks. So I have a little loop set up here. So let's measure the loudness over that loop for each track. So first I'm going to get my loudness meter up. And you'll see that already our units are in LUFS. And integrated basically means for the whole section of time that you want to measure for. So that's the measurement that we want to make. So I'm just going to unmute that, hit start, and then press play, and we'll see what the reading is at the end. So we can see there that we've got a final reading of minus 7.4 LUFS for that section of audio there in levels. So now let's measure Grieg. So for Grieg, we have a reading of minus 37.8 LUFS. So we've just taken our LUFS measurements, integrated LUFS measurements in Logic. So now let's see what would actually happen to that in the real world. So for Spotify, the guidance from their website is that we adjust tracks to minus 14 dB LUFS. And they also have a loud option at minus 11 LUFS and a quiet option at minus 23 LUFS. So let's go back into Logic and normalize our tracks. So here we are back in Logic, and now if we want to replicate Spotify's loudness normalization, we have to remember that 1 LUF equals 1 dB. So here we have Grieg, and I remember that Grieg's loudness was 37.8 LUFS, minus 37.8 LUFS. So to normalize that to minus 14 LUFS, we just have to raise the gain, the volume, by the difference. So the difference between 37.8, minus 37.8 and minus 14 is 23.8. So what we're going to do is we're going to simply add a gain meter and add 23.8 dB of level. And now, when we measure our loudness, it should measure minus 14 LUFS. Let's do that. Yep, so here we have minus 14 LUFS now for Grieg. So now let's apply the same process to levels. So if we go to levels, I remember that levels was minus 7.4 LUFS. So to normalize this to minus 14 LUFS, we essentially just lower the level by minus 6.6 dB. So let's get a gain meter on there and take away 6.6 dB of level. And now this should also be minus 14 LUFS. So yeah, now we also have minus 14 LUFS for levels. And what's really cool about this is now both tracks, which were originally really different in volume, in perceived loudness, should now be about the same. That's essentially how Spotify goes about loudness normalization. Here we are back with the slides, and yeah, so what we did there was we normalized loudness to Spotify's default level, and really the process would be the same for all the other services as well. The only difference is we might be normalizing to a different level. So for example, for Netflix, instead of aiming for minus 14 LUFS, we would aim for minus 27 LUFS. So the amount that we're changing our gain by, the amount we're raising or lowering the volume by would change. And yeah, for BBC television transmission, it'd be minus 23 LUFS instead. So that same process can be applied to many different services. These were the references I used in my presentation, and thank you.